In this video, we are going to go over some common trig identities that you are going to encounter in your trigonometry course. So this video will be helpful regardless if you are starting trigonometry or if you are studying for your final exam. We are going to start with the definition of some basic trig ratios. Now look at the right triangle. The side opposite to the angle theta is called opposite. The other side is called adjacent. And the side opposite to the right angle is called hypotenuse, which is always the longest side of any right triangle. By definition, sine of theta is equal to opposite over hypotenuse. Cosine of theta is adjacent over hypotenuse. And tan of theta is defined as sine over cosine. Crossing out hypotenuse, we have that tan of theta is equal to opposite over adjacent. Now look at reciprocal identities. These are just reciprocals of the previous three identities. Cosecant of theta is equal to 1 over sine of theta. Secant of theta is 1 over cosine of theta. And cotangent of theta is 1 over tan of theta, which is cosine over sine. Actually, you don't need to remember these. What you need to know is their reciprocal relations. Remember that they are reciprocals to each other. So we can also get these relations as well. Now I am going to illustrate these identities by some examples. If the opposite is A, the adjacent is B, and the hypotenuse is C. So sine of theta is opposite, A, over hypotenuse, C. Cosine of theta is adjacent, B, over hypotenuse, C, and tan of theta is opposite, A, over adjacent, B. Cosecant, secant, and cotangent are reciprocals of sine, cosine, and tangent. Now next thing we need to be familiar with are Pythagorean identities. We have known that sine of theta is A, over C. If we square both sides, we can get sine squared is A, squared, over C, squared. Similarly, cosine of theta is B over C. Squaring both sides, one can get cosine squared equals B squared over C squared. Adding them together, we have sine squared plus cosine squared equals h squared plus b squared over c squared. But according to Pythagorean theorem, h squared plus b squared is c squared. So we have sine squared plus cosine squared is equal to 1. Now divide both sides by cosine squared. We know that sine over cosine is tan, cosine over cosine is 1, and 1 over cosine is secant. So now we have another identity, tan squared plus 1 equals secant squared. We can also easily get 1 plus cotangent squared equals cosecant squared. So these are the three commonly used Pythagorean identities. Number 4 is complementary angle identities. If theta is one angle in a right triangle, another angle must be 90 degrees minus theta. These two angles are complementary to each other. Sine of 90 degrees minus theta is equal to opposite, which is B, over C. But cosine of theta is also equal to B over C. So sine of 90 degrees minus theta equals cosine of theta. We can also easily prove that cosine of 90 degrees minus theta equals sine of theta. Tan of 90 degrees minus theta equals cotan of theta. Cotan of 90 degrees minus theta equals tan of theta. Secant of 90 degrees minus theta equals cosecant of theta. And cosecant of 90 degrees minus theta equals secant of theta. These are some examples. If we use radian instead of degree, we can use pi over 2 for 90 degrees. These are the same complementary angle identities with radians. Even and odd identities. Do you remember even and odd functions? If f of negative x is equal to f of x, we say that the function is even. Graphs of even functions are always symmetric in y-axis. On the other hand, if f of negative is negative f of x, it is odd function. Odd functions are symmetric in origin. Now look at sine of x. First, we graph it. From the graph, we can see that the curve of sine is symmetric in the origin. So we can say that sine of x is an odd function. That is, sine of negative x equals negative sine of x. Now look at cosine of x. Its graph shows that it is symmetric in y-axis. So cosine of x is an even function. So we have cosine of negative x is equal to cosine of x. Since tangent is sine over cosine, which is odd over even, we know that odd divided by even is still odd. So we have tan of negative x is equal to negative tan of x. Similarly, cosecant is odd because sine is odd. Secant is even because cosine is even. And cotangent is odd because tangent is odd. So here, we have 4 odd functions and 2 even functions. Next, let's look at the sum and difference identities. Sine of x plus y equals sine x cosine y plus cosine x sine y. And sine of x minus y equals sine x cosine y minus cosine x sine y. Now pay attention to the signs. Notice the order. Positive is followed by positive, and negative is followed by negative. But cosine x plus y equals cosine x cosine y minus sine x sine y. And cosine x minus y equals cosine x cosine y plus sine x sine y. So positive is followed by negative, and negative is followed by positive. You can compare these two pairs to help memorize them. Now the next sum and difference identity has to do with tangent. You'll also have to notice the change in signs. The order of signs is positive equals positive over negative, and negative equals negative over positive. Next one is double angle identities. Double angle identities can be directly derived from sum and difference identities. We know that sine x plus y equals sine x cosine y plus cosine x sine y. And sine of 2x is sine of x plus x. Now we just need to simply replace y with x. And we can easily get sine 2x equals 2 sine x cosine x. Similarly, cosine x plus y equals cosine x cosine y minus sine x sine y. And cosine 2x is cosine x plus x. Replace y with x, we now have cosine 2x equals cosine squared of x minus sine squared of x. Remember that sine squared of x plus cosine squared of x is equal to 1. So sine squared of x equals 1 minus cosine squared of x. And cosine squared of x equals 1 minus sine squared of x. Combining these, we can then derive other forms of cosine 2x. One is 2 cosine squared of x minus 1. Another one is 1 minus 2 sine squared of x. We can use the same method to derive the formula of tan 2x. Tan x plus y equals tan x plus tan y, over 1 minus tan x tan y. 2x is x plus x. Then replace y with x. We now have tan 2x is equal to 2 tan x over 1 minus tan squared of x. Now it goes to power reducing identities. If you are going to learn calculus, you will know that you cannot solve the integral questions such as integral of sine squared and integral of cosine squared without using the power reducing identities. We have already derived the formula that cosine 2x equals 1 minus 2 sine squared of x. By isolating sine squared of x, we now get sine squared of x is equal to 1/2 of 1 minus cosine 2x. From the formula, cosine 2x equals 2 cosine squared of x minus 1. By isolating cosine squared of x, we can get cosine squared of x equals 1/2 of 1 plus cosine 2x. From the fact that tan equals sine over cosine, we can easily get the formula, tan squares of x equals 1 minus cosine 2x over 1 plus cosine 2x. Next one is half-angle identities. I am not going to spend time to prove them. I just list them here. But from the identities of sine and cosine, we can directly get the formula of tan, because tan is sine over cosine. These are product to some identities. They are useful in calculating integrals in calculus. And I just list them here. Last one is sum to product identities. Notice the sign orders. In today's video, we reviewed 11 trig identities. Of the 11 identities, number 1 through number 8 are important and more commonly used. So I suggest viewers remember them. Actually, it's not too hard to remember them. There are some rules to follow, such as sign orders. You can also remember them in pairs. There are some similarity in pairs, like sine and cosine, tangent and cotangent, and cosecant and secant. The more you use them in your practice, the more easily you memorize them.